Well, good morning, everybody, or good afternoon, depending on which end of the country you're living on today. Appreciate you coming out for the November 2025 edition of our uh, On Track Live webinar. We took a month off last month while we were together for our fall meeting, but we're back now. Have a great guest, so I'm not gonna slow things down with a lot of preview stuff here. Reminding everybody, I've got the chat box open if you'd like to put questions in the chat box. I'll keep an eye out for those, and then of course as we always do, we'll have a little bit of time at the end of the presentation here to do Q&A with our guest. We had promoted earlier that we were going to have Dan Connell from Core Natural Resources with us. Dan wound up with a last-minute conflict, but was kind enough to provide us an excellent speaker from Core and his replacement. Rudy Olson is the director of new technology at Core Innovations, and he's got a great resume. He's got a PhD in materials science and engineering from Northwestern University, and has extensive materials engineering expertise and experience in process improvement and new product development. Rudy's worked in a bunch of different sectors, including building materials and ceramics and carbon foam, and a whole bunch more, as we're about to find out. And I'm really excited for this presentation because we spend so much time talking about coal and its use in the power industry, obviously, but there are a whole bunch more things that coal can be used for and that are under development now. So Rudy, really appreciate you taking time out of your schedule to meet with us today. Why don't you go ahead and share your screen, and we'll get started on turn the time over to you to get started on the presentation. And again, if anybody's got questions, feel free to go ahead and put them into the chat box there, or hang on toward the end. We can have a little Q&A at the end of the session. So, you know, Rudy, I can see your slides. You get that in presentation mode, and we'll turn the time over to you.
Here we go. Hey, well, thanks, John. Appreciate being here. And as you said, Dan had that conflict, and it has to do with a lot of the work we're doing currently. There's as you all can imagine, and so. But I appreciate being here. As you mentioned, I'm more of a materials guy, and I could say so. I'm originally from Chicago, not West Virginia, and when I was actually Seafoam at the time and started interacting with Consol Energy. I came in with the mindset of just thinking that, well, coal is it's an organic material and it's a source of carbon. I really wasn't thinking of it as a fuel or as a material that made coke. And so I kind of came into it out of left field with a different perspective, and went right into trying to utilize coal to make products. So as the title here says, Coal Reimagined, that's really what we're trying to do here at our innovation center, is to look at coal more as a source of carbon, or even as a precursor itself to do things in industry, in commercial markets. So let me go right into our presentation. Consol Energy and Arch Resources merged to form Core Natural Resources. And that changed the breadth of our organization quite a bit. Where Consol Energy was really somewhat limited to the East Coast there, Western Pennsylvania. We had a mine in Itman doing a metallurgical coal, and then of course owned the Baltimore Marine Terminal. But then emerging with Arch, really a similar size company that provided a number of additional mines in West Virginia, but then also gave us the full company also had a presence on the West Coast as well, with Wyoming and Colorado, added some additional terminal capacity. And so we now have a more of a nationwide presence. And it's really, for us, has opened up potential to utilize different coals for some of the different markets that we're looking at.
Hey, Rudy, can I interrupt just a second? I think
Yeah.
on the display we've got we're kind of frozen on your lead title slide on
Oh,
the
really?
display. Yeah, I've got the blue
Gosh.
spinning wheel. Got the blue spinning wheel depth there
Okay.
right now. If you could maybe back out and get back
Okay.
in, that would be great.
Yeah. Nothing's moving there.
Well, the blue wheel went away. Why don't you try hitting that little presentation mode button down on the very bottom there again one more time? See if it
Try
pops up.
that. Yeah. Let's see here.
There we go. Now we're caught up with you. We got the now we're on the Coral Natural
Okay.
Resources at glance page. So thank you for
Okay,
that.
great.
Sorry for the
No, yeah.
interruption.
And I'll tell you, interrupt me again if I'll notify you as we go. So as I mentioned, you can see here on the map, Pennsylvania, West Virginia, the ports in there in Maryland and Virginia. We have Wyoming and Colorado, and also some ports there in Vancouver and Long Beach, Houston and New Orleans as well. Accessible terminal capacity there. So yeah, for us as the innovations group, it really helped broaden our the ability to access different types of coal, which as we go, you'll start to see that can be important. So you can see slide 3 there. Did that transitioned? Okay.
Actually not. I'm still on Core
Okay,
Resources
shoot.
at a glance here. So.
Let's see. I wonder if maybe what if I keep it out of presentation mode? Do you see the vision there?
Yeah, now we're on vision building. So yeah, let's just go that way.
Maybe we'll try that way. Okay.
Perfect.
So the vision's important. Historically, I know Consol Energy had been around 160 years. Was just 1 year short of of when the state of West Virginia was formed in 1863. Consol Energy got started in 1864. So what has Core and Consol and Arch done for quite a long period of time? Well, they've supported infrastructure development, urbanization, and transportation through metallurgical coal to make steel and industrial coal to make products like cement and other materials. And then, of course, thermal coal provided reliable and affordable power generation. So what is Innovations trying to do? We're elevating Core's mission by developing, commercializing new technologies that have the potential to transform how our coal and carbon resources can be used to meet society's most pressing needs into the future. So on the left side, for infrastructure development, what are we using coal for? We're into aerospace and advanced materials, and also building products. You could see obviously the some advanced aerospace planes and related, and then building products. One of our main products is a deck board, decking composite material, which I'll be talking about. But then on the power generation and energy side, we have batteries, and we also have carbon management. So in a lot of ways, we're servicing the world and the country in the same markets and in the same areas, but doing it through different technologies. So slide 4 here, using coal as a resource to tackle humanity's greatest challenges. Some of the arenas we're in, carbon fiber, composites for aerospace. That demand is projected to grow from 20 billion to 40 billion by 2035. So that's within 10 years, going to double. It's driven especially by the need for lightweight, high performance materials in aerospace and transportation applications. On the top right there, the world is going to need to build about 2 billion new homes by the end of this century. And for perspective, that's about the number of homes that we have on the planet today. So in 75 years, we're going to need to double the number of homes on the planet. That sourcing sustainable materials are going to require new innovations. It turns out if you add up all the wood, steel, and concrete on the planet and calculate what's going to be required, that's just not enough. And if you look around and say, well, what other materials are available in the same scale, there's just not that many. And it turns out coal is one of those materials. So we're looking at it from that perspective. Bottom left there, battery demand expected to grow at greater than 20% per year through the next 6 years, through 2031. But it turns out the U.S. needs domestic solutions because greater than 98% of battery-grade graphite comes from China. That means anytime you see a lithium-ion battery, that anode is made from graphite, and 98+% of that comes from China. So we really need not only domestic supply, but we need new materials that can perform as good or better than graphite. And then on the bottom right there, the voluntary carbon offset market has been projected to reach $250 billion by 2050. Coal and other fossil fuels are an essential component in even the most stringent emission reduction scenarios, but there's still a need for more viable carbon management technologies. And we'll talk a little bit about that as well. So the Core Innovations model, we're an LLC that sits underneath the parent company. And we're really about looking to commercialize these innovations. We're not a big R and a small D. We're really a small R and a big D. We're trying to take good ideas, innovate those ideas, but then transition to a testing stage and then a scaling stage. So underneath the innovation stage, you can see some of the areas that we're working on. CBAT is actually a joint development between Core Innovations and XBAT down in Florida, where we're looking to displace graphite in lithium-ion batteries using a pre-ceramic polymer / coal composite. But in the testing stage here, you can actually see we've graduated some of our newer technologies, one being the coal plastic composite decking and the Comet methane mitigation technology. And those are transitioning to the scale stage as we speak. But then we do have some that are in that for-profit manufacturing stage. And that includes our Touchstone Advanced Composites business and our Seafoam manufacturing process. And that is a for-profit business. We are not only making tools for aerospace to make carbon fiber composite parts, but we are now also making aerospace parts off of those tools. So we are vertically integrating up the food chain, but at the core of it sits coal as a precursor. And there's some reasons why we like coal for that process, and I'll talk a little bit about that later. So, what's the goal? Is create new business units large enough to provide meaningful diversification within the next 5 to 10 years. Initial focus, gaining a foothold in large, high-growth markets. So building materials, aerospace, advanced materials, batteries. Identifying niches where we can bring a clear value proposition, enter and disrupt. Model a structure to learn quickly, direct resource, highest potential opportunities, scale only after profitability has been demonstrated. A little bit about our footprint. We're largely located on the East Coast here. I think that probably is because we really started with Consol Energy. I do feel like that could graduate to the West Coast as we go now that we've merged with Arch. You can see our headquarters is in Canonsburg, PA. We actually have a pulverization facility in Blairsville, Pennsylvania. That's the top right there where we pulverize our coal to make seafoam carbon foam. Touchstone Advanced Composites is in Triadelphia, West Virginia. It's about an hour southwest of our headquarters. That's where we're making our carbon foam tools and aerospace components. The Comet demo unit is in Rich Hill, PA. That unit is that technology is based on processing low concentrations of methane from coal mines. Our carbon product offices and labs is also in Triadelphia, West Virginia. It's really where our skunk works are located for developing these new technologies. Talked about our CBAT joint development. That's located in Oviedo, Florida, just outside of Disney World and Universal there. Nice place. And then we're currently building our first commercial production line, our coal plastic composite deck board manufacturing effort in Columbus, Ohio, through our partner Engineered Profiles. So that's really our footprint. So before we get into some of the applications here, I'll look at these notes. Why coal? Coal is turns out it's extremely versatile. Could be used for used to engineer materials, create materials with a wide range of properties. And seafoam is an example of that. So what do we do to make seafoam? We pulverize coal and we put it in a metal pan and we cook it like a loaf of bread. Now we do that under high pressure in an autoclave. There's some conditions that we have to meet to make that work. But what do we end up with? We produce a vitreous carbon foam that's fired up around 1,000 degrees C. It could be fired as high as 3,000 degrees C if desired. We end up with a product, as you can see on the right there, which are bonded pieces of carbon foam that have been machined into a half a cylinder. The product has low density, it's lightweight, it's fire resistant. You would think coal might be somewhat affected by heat, but it turns out as we go through this process by firing the coal in an oxygen-free atmosphere and converting it to vitreous carbon, turns out that material is very fire resistant. You could hit this block with a blowtorch and it would never ignite. So you can do some very interesting things where, putting it onto aerospace components that might be traveling in, under hypersonic conditions, and you just need a material that's not going to melt, even though it might oxidize, to do well to protect, say, electrical components for some period of time. You can go on here, corrosion resistant, it's highly machinable, has a very low coefficient of thermal expansion. That means when we create a mold and you're making a high tolerance carbon fiber part, you don't want that mold to grow a lot and then shrink. So the low thermal expansion's quite important when it comes to making aerospace parts. Very thermally stable at high temperatures. You can actually tune the electrical conductivity over about 8 to 9 orders of magnitude. So it can actually function as electromagnetic shield, like a Faraday cage. So there's some interesting things there. You hear stories about people jamming drones by shooting electromagnetic waves to disable the communication to the control unit. Something like carbon foam could actively shield those electromagnetic waves and combat that effect. So we can leverage coal to create these engineered materials with a wide range of properties, creating ample opportunities to innovate coal-based products to meet the needs of future-facing applications. Very abundant natural resource. U.S. leads the world, of course, in proven coal reserves. So here we're trying to use coal in entirely new ways to meet unmet needs of the future. So here's another example. Would you have guessed that some of the world's most cutting edge aircraft, and I don't know if I could do this as well as Dan. This actually started with coal. So you may have seen in the news recently, the X-59 just made its first flight. So this is a plane that was designed to break the sound barrier, but not create a sonic boom. I think there are a couple of companies out there that are working on this technology. And so, yeah, what does coal have to do with the X-59? So you can see in the top left here is a panel of carbon foam made along the lines of what I described earlier. That's basically our loaf of bread, right? The coal gets baked, it foams up, it fuses together. And then we take those panels and we create a near net shape of an object that we're trying to reproduce. So in the middle there, you can see we'll take that sea foam and bond it up together, just using enough to create that net shape. And then on that top right, you see a finished piece after it's been machined in a CNC. And so at that point now, the only thing you really need is a high tolerance surface. And so that bottom picture is the finished unit where it's been surfaced with a graphite infused epoxy special material that also has relatively low coefficient of thermal expansion, can be machined. And now we have a plus or minus 5 thousandths tolerance over that entire shape that can be delivered to a customer or used here to create a shape. And that's exactly what we did for the X-59 here. You can see at the top left, that's the tool that was used to make the nose. Obviously, the nose piece here is very long and thin and has to be made to very exacting tolerances. And so seafoam was the perfect tool because of its low thermal expansion. And so, right, you say, okay, well, how many other customers might you have? And really, we've been working with aerospace companies for quite a while. And you see all the big names here: Northrop, Lockheed, Boeing, Anduril, Kratos, Rocket Lab, Firefly, Sierra Space, Textron, NASA, seafoam tools in some form or fashion. And now we are looking to graduate into making parts off of those tools. We did just add 12,000 square foot clean room onto our 40,000 square foot manufacturing facility. So that's going to grow by almost 30%. And we're looking to fill that capacity. I'll switch over here to our deck boards. We talked about building materials, right? And the opportunity here. We're going to need to build 2 billion homes by the end of the century. One of the products we're focusing on is a coal plastic composite. So you can see on the left here, over the last 60 years, 8 billion tons of plastic have been produced around the world, but only 9.5% has been recycled. it turns out we've been able to make a composite where we've introduced coal waste fines as a filler material uh, into the plastic. In this case, it was a PVC foam. And so we are displacing some of the plastic that's used as a precursor, so effectively saving materials and saving costs, but then also repurposing the waste coal fines as a sustainable alternative for building material. The U.S. has hundreds of millions of tons of fine coal waste, contain up to 50% carbon. And you can see on the right there, not only are we looking to do decking materials, but we're starting to experiment with piping and also other plastic extrusions. A lot of this started with Ohio University several years ago, where Consol was the one who was supplying the proper coal and precursor materials for that research. And we continue to work with OU and our partner Engineer Profiles, and we're looking to grow this concept as we go. And so you can see here on the very left, 2018, we started with beakers full of plastic and some chunks of coal. Excuse me. And then on the top right there, you can see how we started on the left with very small extrudates, and as you go to the right, the decking boards got better and better until finally in 2022. There you see we made our first deck at Home Innovations Center. But then over the last couple of years, gotten into manufacturing runs. You see on the top right there is a deck we built just outside of our facility. The one on the bottom left is actually is a handicap accessible deck for the baseball field at West Liberty University. Bottom right, we've done a lot of work at the Oglebay Zoo. You can actually see an albino alligator peeking its head out of there. We're testing, exposure to water, how it's going to hold up over time. The albino alligator makes kind of a nice picture. But yeah, really excited about that product. And we hope by the end of 2026, we expect we potentially have the capacity for about 2.5 million linear feet per year by the time we're done. Talked a little bit about batteries, our CBAT effort. And graphite is actually in the danger zone for the US DOE Material Criticality Matrix 2025. You hear about all these rare earths, neodymium and related dysprosium. Well, graphite is right in that same spot. So this effort's actually it turns out coal, when added to pre-ceramic polymer to create silicon oxycarbide carbon-rich materials, it improves the performance of the silicon oxycarbide glass to the point where you see on the chart to the right there, we're calling this new material Obsidia, which we've trademarked. When you start to compare it to graphite and to silicon, we have some terrific properties. The specific capacity is not as high as silicon, but it doesn't have the volume expansion issues that silicon has, and it also has a very low cost. We can fire this silicon oxycarbide material at much lower temperatures, and then of course utilizing coal, we can reduce that cost even lower. So we're working to scale that material up, and we've already made batteries. You can see on the top right there, it's actually a pouch cell that contains waste coal fines. And there you're showing the pouch cell. It's about what you'd use in a cell phone. And there it's just an example where it's powering some LEDs. And this one, I can't say too much about it other than um, I'm a little bit unfamiliar, but our guy Steve Winter uh, in our innovations group is the guy who's heading up this project, and basically uh, we are looking to process the low concentration methane that comes from mines. I think from my simple perspective, the high concentration is kind of easy to deal with because you could just flare it. So low concentration gives you the trouble. And working with our partner Johnson Matthey, really using that more of a catalytic approach. Um, we're successfully implementing this technology. I believe it's potentially applicable to over 125 U.S. mainline air shafts with an average methane concentration of about 0.2%. So we are working with Johnson Matthey at the pilot test site at the Bailey mine, and this was funded in part by U.S. DOE ARPA-E program. And you see on the right, that's a real picture. This unit is functioning, working out the bugs, and feel like by the end of this year, maybe another 6-7 weeks, we're really going to lock the process down and consider our next steps in 2026. So with that, these are some of our main examples, but here we still have a robust pipeline of opportunities. I guess that's one of the dangers is often you're not short of ideas. You really have to manage the ideas, make sure you don't go a mile wide and an inch deep. But same token, if that's the job that we're trying to do is innovate, you can see on the left that example I was talking about. High temperature torch, acetylene torch. The sea foam's just not going to melt. So there's some really interesting high temperature applications we're in. With Ohio U, we actually developed a coal-based 3D printing technology. One where not only could we print plastic, but we could also print a carbonizable precursor to create 3D printed carbon objects that could survive to 3,000 degrees C. On the right there, we actually we created a novel carbon aggregate. Thinking there is, you've probably seen 60 Minutes maybe or elsewhere, these 3D printed homes. And one of the issues there is you really have to control the rheology of the concrete. And it also turns out 3D printed homes don't rely considerably on the strength of the concrete because it still uses steel as its infrastructure. So what you really need is a well-controlled, lightweight, rheological, good rheology control in your concrete. And so what we created was a lightweight carbon aggregate, similar to some of the lightweight aggregates that are out there today, like in High Point, North Carolina. And we're looking towards that we feel could be a very high volume building product. Could potentially use waste coal fines to make that product. Bottom left, you see our Skunk Works. We actually have a belt kiln there. It's about 68 feet long. You see our coal plastic composite pipe. Bottom right there are actually some filament, coal bearing plastic filament being produced there. A couple others. 2024, we actually took part in two of Time Magazine's 200 Best Inventions of 2024. If anybody watched the Paris Olympics, turns out the gold medal winner for the women's group in the marathon broke a new Olympic record, was actually wearing a graphite foam Ohmius headband that contained our graphite foam in it. And then on the right, the NASA solar sail, those carbon fiber composite booms that unrolled the kite. Those were made on Seafoam tools. Again, very long and skinny, very thin carbon fiber structures. They had to be made to very exacting standards. And it turned out Seafoam was the right tool on which to make that product. I'll give you a little heads up. If we got any runners out there, if you go to the Ohmius website, www.ohmius.io, you put in the coupon code CONSOL10, you'll get 10% off the headband. It is $200, but that'll save you $20. And
what does the headband do for you? Does it make you run faster?
So it's So according to these high-end athletes, one of the most important parts of your body you need to keep cool when you're competing is your brain. And so the graphite foam, being porous, it's actually impregnated with a hydrophilic coating, and you get water in it or sweat, and of course that water is going to evaporate. But the graphite foam is lightweight, and it's also very thermally conductive, so it will continue to pull heat away from your brain. And the argument is that it could. So if you're a marathoner and you're trying to shave a few minutes off your time, maybe that's the way to do it. I could tell the silver medalists for the men's, and I think the bronze medalists for the women's also wore a headband. So this is Hassan crossing the finish line here. This is made with a special material called Mesaphase pitch. You can make it from coal. You can also make it from petroleum. We're continuing to do work here, but this is a great product, very innovative. It was invented by a guy named James Klett at Oak Ridge National Lab 25 years ago. But for materials, often, some of these more unique ones takes a long time for them to really come around and make an impact. The last one I'll leave you with, and Dan likes this story. I like it too. Telling our story is the key to the future. So here's, it turns out Wheeling Country Day School, which is right nearby our town of Triadelphia. Wheeling, of course, a little more well-known. The fifth graders who knew about Seafoam decided they wanted to send Seafoam into space. And so what did they do is they took a couple of chunks of Seafoam, glued it to some popsicle sticks, and put it on a weather balloon. And you see that's the first picture they took of their school. And then this is the second picture. Anybody who's been to Wheeling Island, the casino there, that's the Ohio River, and Wheeling Island is right in the middle, right next to Wheeling. And they got to 95,000 feet, pretty much the edge of space. And so the Seafoam, for them, it was a huge accomplishment, and the fact that they chose our material to bring up in their mission was terrific. Anyway, I think that's all I got, and I'll leave you with this QR code. It's a marketing effort that Consol and Arch and Core have put together. You want to learn a little more about some of the things we're doing, I think you can pick it up there. You could also go to www.seafoam.com and catch a little bit more of what I've been talking about there. So I think that's all I got. I'd be happy to take any questions.
Yeah, very, very, very cool stuff, Rudy. Thank you so much for giving us that overview. We do have a few questions already in the chat, and I've got a couple too. So if anybody does have more questions, feel free to type them in the chat or unmute yourself or do the Zoom wavy handy thingy or whatever. But real quick on all of this innovation that you're working on at Core, how many of these things, how many of these things we just went over would qualify as, the secret sauce, patented things that would be just ours, and how many of them would fit into the category of a rising tide floats all ships? I mean, once you start having commercial success with this stuff, that others may be able to step in and do it too.
Sure, that's a good question. I think you know, we do have the opinion that rising tide lifts all boats. I think the more that something like coal could be incorporated as a building material, just leads to greater acceptance. I think if a second or third company was doing similar things, and we do see other folks in the coal mining space kind of adopting some of these methods. Not everything we're doing is can be patented or is patentable. I could say, a lot of what we're doing, of course, we might, if it's a trade secret, we're going to try and keep it as a trade secret. But the same token, I think we feel like a greater acceptance of coal would be the greatest thing that helps our efforts. And I think we would encourage other companies to take part and kind of to follow the same methodology. If we could lead the way, that's fantastic.
Absolutely. How many of these technologies are coal rank dependent? I mean, can I make seafoam out of bituminous and subbituminous coal, or how does that?
That's really good question, and coal rank is important. And it's important in a lot of these technologies across the board. I think that's where some of these things it isn't. It may look easy from the outside, but you really have to have a good understanding of coal, which I think right companies in the coal mining industry happen to have. But for instance, seafoam, you can't go too high or too low. So, anthracite and lignite don't make good seafoam. It's kind of those caking coals in the middle, kind of in that bituminous, subbituminous. And there is potential. We have learned how to blend coals. So you can almost vary the properties of the seafoam, its density, its mechanical properties by learning to vary the amount of coal with a given coal rank to make the product.
Yeah, exactly. I noticed too that a lot of your technologies you're working on are coal, but then we've also got waste coal resources in there. Is it?
Right.
I mean, could you? I mean, do you prioritize one over the other, or is it more just we're selecting a technology and figuring out which one's going to work best?
That's a good question. In that, with virgin coal, of course, you're having to reduce that particle size, whereas the waste coal fines are already fine, but they're also laden with mineral matter. And in some cases, you'd say, well, look, I like the fineness, and in this particular application, the mineral matter is okay; it doesn't impact me. But maybe if I can beneficiate it, just the work that Virginia Tech is doing, some other folks, Virginia Tech, I think, is kind of leading the way on this. Could you beneficiate that coal waste fine to where you're moving that mineral matter maybe down to levels of 3%? And now you're 97% coal and you're already fine. And maybe you like that for a particular application. Whereas the virgin coal, you're saying, okay, maybe I don't necessarily want to start with the waste coal fines because my process is more tuned to grinding that virgin coal to a very specific particle size that maybe I don't control as well as the waste coal fines, but I have more control in my process.
Right.
Excuse me. So there's reasoning as to which one you might want to use. I think from the standpoint of trying to use a waste material and not, divert it from going into an impoundment, that would always take precedent if that's a preferred, if you're ambivalent to which type of coal you're using, you'd probably opt for that way.
Yeah, the big shiny object in the room lately, of course, has been rare earth element recovery from coal. Right. You pointed out that graphite and the things that work like graphite are on that endangered species list that we have of stuff that we need to get Are you guys looking also at rare earth element recovery, either from the coal
Yeah.
resource or the coal waste?
We are, and that's something that, like you said, that especially the last few months has really been ramping up with the new administration going into 2026. So we are doing that, but at the same time, we feel like the efforts that we're working on with our CBAT program and our joint development there, we're we're addressing those same concerns, but we're not doing it through just trying to mine more material or do something in a more conventional way. We're actually trying to address the critical mineral problem by actually creating new technology using coal that is very prevalent and not rare, but we're actually supporting the supply of material that's critically needed.
You specifically called out graphite as one of the key ones that obviously China has, controls 98% of the supply for. Are you looking? I was a little confused. Are you looking at making graphite or making graphite substitutes or both?
Good. So making graphite substitutes. That the material we're making, the silicon oxycarbide material, is actually we only have to cook it to a little over 1,000 degrees C, whereas graphite you actually have to make up around 2850 or more. So very, very different process, and the properties are actually as good or better in a lot of cases than graphite. There might be reasons why you might want to blend the two materials, kind of like you do with silicon, but it kind of depends on the performance of the battery, what you're looking to design. So we'd be inclined to displace graphite so that you don't have to buy as much from China.
Right. Interesting. You also mentioned, a couple of universities you've worked with, Virginia Tech, Ohio, obviously coal country technology universities, and then the NETL grants. I mean, yeah, how does that, you're doing basic research. How much does your program depend on the government funding and those collaborations with the academic institutions?
That's a good question. I could say it doesn't have a significant dependence. I could say, we have the luxury of looking for opportunities there. I think when we see good opportunities to work with the university or with the government, we'll take them. But at the same time, we're not a grant mill. We're not dependent entirely on universities. I think the way we're set up, we put a lot more focus on the development part. So earlier when I said little r and big D, we're not focusing on doing a lot of heavy basic research. That tends to be pretty costly, takes a lot of effort, and really we recognize it's the development part that really is probably the more difficult step in the process. But people talk about the valley of death.
Yeah.
TRL 6 and 7, and you're going, well, that's the hard part. So there are a lot of, when you can rely on universities and the government to create those seeds and get to TRL 3, they go, hey, somebody please license this technology from us, right? And so to find good partners who can do that, Ohio University the decking material is a perfect example of where they started it, they took it to a point that they got it to a point where they didn't want to take it any further. We picked it up and we've commercialized it into a technology that we're now we're looking to start selling that product next year.
And the old aphorism is everybody wants to be the first person to build the third plant, right? That's
there you go. Yeah. Right.
Take the risk out of things. Exactly.
Right.
But where I'm assuming where you do have some secret sauce or proprietary know-how, Core is going to be in a position to want to license that technology for, let's take that decking product, for instance. You get a factory up and running, it's working. Other people have, waste impoundments with coal fines and so forth in them.
Yeah, exactly. And look, and one thing I'll give Core, they're a very smart, financially driven company. There's a reason why Core is a real solid company doing well. Is look for good business opportunities. So I think potentially if those emerged with other companies, I don't see any reason why Core, I don't see any reason why they wouldn't consider that.
Yeah, wouldn't license those kind of things. Had one other question on the methane abatement technology. I would suppose the economics for that probably run both to regulatory compliance and the carbon credit market that
Right.
you discussed.
And that's something I don't know a whole lot about the carbon credits. I just know, like you say, that's
part of the
it.
economics for that one, isn't it?
Yeah, and of course that's continuing to change as we go. But I think you saw there was a $250 billion coming over the next several years. So that will be a factor, and yeah, we think and it's a win-win.
Yeah.
Not only are you making something that's commercially viable, but you're improving your environmental controls in this industry.
Yeah, one of the newsy updates. I mean, just this week or late last week, DOE came out with another notice of funding opportunities, another $336 million out there for some of these, some of these technologies for critical minerals recovery and state of the art coal mine technologies. So this administration, is preparing to put his money where its mouth is on these coal resources. So.
Yeah, I think that's why Dan had to miss this meeting.
it's got a very short deadline for the application. So
exactly. So right, I think that dropped on Friday, and so I think Dan entirely planned on being here until that dropped Friday, and then things got scheduled today.
Yeah, so, no, it's like most things coming out of the Trump administration. There's very short deadlines on getting your act together on this stuff.
So we're jumping on it.
We're coming up on the end of the hour here, kids. So if you have any other questions, now time to bring them up. I could talk about this stuff forever. Let me ask you one other kind of out of the box question, Rudy. Is I noticed that you did come up with a trademark name, Obsidia, for your graphite replacement business. I know in the past people have tried, so maybe when coal wasn't as favorable a term as it is coming around to be again, people have tried to call it carbon ore or other give it maybe a different name to change the perspective. How critical do you think that is to commercializing some of these technologies? Do we need to separate them from coal or are things changing now to where we can just own up to it? Hey, this is a good use for good old fashioned coal.
That's a really good question. I think when it came to government, I could tell you that the needles bounced back and forth a couple of times. Even my short tenure in the coal space, it went from you could use it to where you couldn't use it. You had to call it carbon ore, and we had active proposals that were in that called out coal. And then the awards went through, but then you had to change the word coal to coal waste. You couldn't use virgin coal; you had to use coal waste in your project. But then it's flipped back again. But I could tell you that's just for the government. I think commercially, it's a completely different story. But I could tell you, when we talk to folks in West Virginia and Southeast Ohio and Pennsylvania, and we show them a deck board, within 30 seconds, I could tell you 99% of the time people are saying, when can I buy this? Where can I go to Lowe's and buy this? Can I go, so the pull is quite good here. And I think the coal culture in this area, people would be attracted to that product. I think California might be different. And it may take a while or similar places, right? I know my daughter who did an internship here when she spent her husband's in the Air Force. She spent some time in Sacramento, and she would tell people that she worked in West Virginia, and then later in the conversation they would say, "Wow, you worked in Western Virginia," and she'd say, "No, West Virginia." And then they later in the conversation they would say Western Virginia again. She'd come to the conclusion that they didn't know it was a state. And I've run into that a couple of times myself. So I think different areas of the country may take some more work, but this messaging. So the cold hard truth, that QR code at the end there, you could Google that. That's part of the messaging, right? That the U.S. coal reserves are the largest on the planet. And if we could figure out better ways to utilize that resource in these new ways, people would use the term coal in a positive way. But right with that, you got to put your money where your mouth is. You got to do the work, and but
Yep.
it's been growing. So
and at the end of the day, it all comes down to performance, right? I mean, I'm a guy who comes out of the coal ash industry and so forth, and California.
Okay.
We
Yeah.
mentioned California as an example. California was an early adopter of coal ash
Right.
in concrete, and that was not because of the environmental benefits at that point in time. It was because it made the concrete perform better, and
Absolutely.
they
Yeah.
needed
It's
that.
been over the
Yeah.
last 20 years, and now, and I just saw, what was there, an article not too long ago saying for the first time, we outstripped the production. Fly ash has been incorporated in so many concrete formulations now that
It's
you suddenly flipped it, and people are starting to ask, well, where are we gonna
yeah.
get the ash from?
Yeah, no, I tell people all the time, I spent the first 15 years of my career going around trying to convince people that using coal ash and concrete was a good idea. And the last 15 years, I've been trotting around the country trying to convince people they're not going to run out of it. So
That's right.
so yeah,
Right, put it in. Yeah. No,
the end of the day, getting these products to perform is what's gonna is going to bring them
absolutely.
across the finish line, and that's
Right.
really exciting, Rudy.
Yeah.
All the different things you're working on. The only suggestion I'd have for you at this point is we need to make a mascot out of your albino alligator.
There we go. All right.
And
We
marketing.
someone talked about we need a mascot for our skunk works, and people were starting to come up with a skunk, but we thought, well, why does it have to be a skunk?
Yeah, let's make it. Let's make an albino alligator. I think we're all there.
Alligator.
So
the big
well,
Seance test. Yeah.
That's awesome. Well, our hour is up. Like I say, we could talk about this stuff a lot. I do encourage everybody to look up that the Coal Hard Truth program that CORE is running. We reference that periodically in our On Track newsletter that comes out every other week, and we'll continue to do so. They're doing great work there as well, in addition to everything that's going on in this product development space. But I think we'll let you get back to innovating things, Rudy. But really appreciate you taking the time to be with us today and broaden our horizons a little bit. It's exciting stuff.
Appreciate it. Honored to get the invite, and hopefully you guys see us continue to churn some stuff out here.
We'll be excited to follow up with you. So thanks again, Rudy. Everybody else, next month we'll be back, same bat time, same bat channel. Should be a really interesting conversation next month. We've got Llewellyn King, who's kind of a interesting character personality in Washington, D.C., former, a naturalized Brit, does a lot of work with the U.S. Energy Association, and kind of has his pulse on a lot of things that are happening in energy politics and the energy transition and all of those kind of things. So we'll have an interesting conversation with Llewellyn next month. So appreciate everybody taking the time to be here. Rudy, thanks again. And I hope everybody has a great rest of the week and a very happy Thanksgiving holiday.
Okay. Thanks, John.
Take care.
See you.